Well, hello, pre-calculus students and general seekers of truth. In this video, we will graph another exponential function, and we'll use our knowledge of transformation in order to graph this. We could, of course, use a graphing calculator as well, but we want to exercise our analytical skills in a problem like this. So we want to graph this function, and we also want to find the domain, the range, and the end behavior. Okay. So I'm going to employ a fairly familiar strategy, which is to relate f of x to a simpler function, of a well-known function that we've just done recently. So we're going to relate g of x equals 2 to the x to f of x. In other words, how do we go from g of x to f of x? And we can understand that, then we can understand the transformations. Okay? So and let's just think about this from what we had before. We know that that g of x looks something like this. I'm just going to give you a quick sketch of this. This is g of x, right? And g of x, has certain behaviors. We know that it's going to go through 0, 1. And so one of the strategies that we are going to employ is we're going to try to write this base 1/2 into the same base as 2. So continuing over here, we know that f of x is equal to 1/2 to the x plus 3, but we can rewrite 1/2 as 2 to the negative 1. Okay, so this again comes down to understanding rules of exponents. So we still have this plus 3 here. And then we can take this a step further and we can multiply these two exponents. I have a power to a power, so I can multiply those two exponents. And I get 2 to the negative x plus 3. And now let's think about what this means in the world of transformations. Well, 2 to the negative, we went from 2 to the x here, right? And we turned it into 2 to the negative x. So this is a transformation of a reflection over the y-axis. Okay, so if you recall our previous work on transformations, this is a reflection over the y-axis. And then this plus 3 here is a shift upwards of 3 units. So we're moving it up 3 units. So let's think about our new graph of f of x, and let's get some nice pictures, some nice axes drawn in here. So there's the y-axis, there's the x-axis. Actually, I'm going to draw the x-axis just a little bit lower here. So here's my x-axis. And instead, and if you compare it to g of x, we are shifting it up 3 units. So instead of going through 0, 1, we know that this will be going through 0, 4. That's the point here. And this graph will be reflected over the y-axis, so it's a horizontal transformation, horizontal flip. And instead of leveling off at y equals 0, it's going to level off at y equals 3 because it's being shifted up 3 units. So if we have this dotted line here, it would look something like so. So this would be like our horizontal asymptote. This would be y equals 3 instead of y equals 0. And with this in mind, we can now answer these questions about range, domain, and end behavior. So the domain of f of x would be still all real numbers from negative infinity to positive infinity. Nothing has changed there. You can plug anything in for x without breaking the function. The range, all the possible outputs or the possible y values would go from 3 inclusive to positive infinity. And the end behavior, well, the limit as f of x approaches, the limit of f of x as x gets very, very large will be 3. And the limit as x approaches negative infinity, as x gets large but in the negative direction, will go towards infinity. So there you have it. Using knowledge of transformations allows us to answer this question quite quickly. and without having to use a graphing calculator. Even with a calculator, you still have to think about what these what this behavior really is, and we want to exercise most of our analytical skills on a problem like this. As always, ask for help if you need it. Thank you for watching. Have a wonderful day. Be sure to check out the other videos when we talk about graphs of logarithmic functions.